Fifth question. In the figure, center of the circles is O. Chord AB of the bigger circle intersects the smaller circle in points P and Q. Show that AP is equal to PQ. Now we have two circles here. You see they are concentric circles. Concentric circles are circles with the same center. So we have two circles here, the smaller one and the bigger one. The smaller circle you see has a chord here which is named as PQ. The bigger one also has a chord which is joined to the chord of the smaller circle, but the chord of the bigger circle is named as AB. Now what have they said? The chord AB of the bigger circle intersects the smaller circle, that is, it cuts the smaller circle in points P and Q, such that what happens? Chord PQ is formed of the smaller circle. What have we to do? We have to show that this part AP is equal to this part PQ. Now what do we do? First of all, we write that segment OM is perpendicular to chord AB, such that now OM is perpendicular to chord AB such that M lies between A and B. So we write A dash M dash B. Okay, now we consider the smaller circle here. The smaller circle, how do we identify the smaller circle? We can't identify with the center because both the circles are having the same center O. So we consider this smaller circle with the chord PQ. Considering the smaller circle with chord PQ, what happens here? Segment OM is perpendicular to chord PQ. How do we know that it is perpendicular to chord PQ? Because if segment OM is perpendicular to chord AB, as we have said here, PQ is a part of AB. Therefore, segment OM will be perpendicular to chord PQ also. Now, what will be PM here? PM will be equal to this MQ. Now, how did we get PM equal to MQ? We are using the theorem, the perpendicular drawn from the center of the circle to the chord bisects the chord. So, we write PM, that is one part of the chord, is equal to the second part of the chord, that is MQ, and number this as 1. Same thing happens if we take the bigger circle. Bigger circle is having the chord AB. So now considering the bigger circle with the chord AB, here similarly considering the larger circle with chord, we write the name chord AB. What happens? Segment OM is perpendicular to chord AB. So I write here segment OM perpendicular to chord AB. Now, I look at this here. I see that AM is equal to AP plus PM. This full AM can be written as AP plus PM. It can be written like this and it is made up of AP plus PM. So, I write here AM is equal to AP plus PM. But you see here, first I have written here that AM is equal to AP plus PM, that I have written here. But before that, we also know that AM is equal to MB because the perpendicular drawn from the center of the circle to the chord bisects the chord. So I also write here that AM is equal to MB. AM is equal to MB, but AM is equal to AP plus PM. Same way, if I consider MB, it will be made up of MQ plus QB. So we write here AM equal to AP plus PM, and if I take MB, look at the figure, MB, it is made up of MQ plus QB. So I write here, it is made up of MQ plus QB. But we already said here AM is equal to MB. So if AM is equal to MB, then what will happen? AP plus PM is equal to MQ plus QB. So I can write here, therefore AP plus PM is equal to MQ plus QB. Now once we get this, AP plus PM is equal to MQ plus QB, we go back to 1 and see in 1 what do we have? PM is equal to MQ, right? So I have written, but PM equal to MQ. So if PM is equal to MQ, then I can cancel PM and MQ on either side. So when I cancel PM and MQ on either side, I get AP is equal to QB. Okay, so I cancel this PM and MQ. So I get AP is equal to QB. That is, what have we to prove? Show that AP equal to BQ, that QB or BQ is the same. So, or AP is equal to BQ.